Goes in the book first.
Number
20. Okay, let's talk about number 20. Now, don't worry too much about number 20. Now, I didn't realize that was in number 20 because remember I said we went through at the end, we went through several kind of weird situations that can happen, and we talked about how you could end up, you do it and then you get a U substitution or whatever in there. And there's another thing, and that's what number 20 was. I forgot that number 20 was that problem. You're not going to have to do a gateway test. It doesn't mean it's not good practice using it, because what you found out, if you spent some time with it, what happened? It just kept circling around, right? In other words, you kept kind of getting back the integral you started with, in a way. Now, that particular one, on 20, it had a 2x inside the cosine. It had a 3x inside the e, so that made it get a little messy with some fractions and stuff. So let me just talk about what happened in that real quick. So what did it start with? E to the x and cosine? Yeah, but I'm just going to leave out the 2 and the 3 just because those don't really affect anything other than they'll be fractions. You have to kick out a 1/3 and a 1/2, when you do your derivatives and antiderivative stuff. So let's pretend it was this right here, okay? And then what was it, from 1 to e? Is that what it was? 4. Or the integral? 1 to 4. 1 to 4. Okay. So it looked like, let's pretend it just looked like that. Okay. So you would start by letting u equal what? This or this? Trig comes before exponential. Liate, right? T-E. Trig before the exponential. So we're going to let u equal the cosine x. Again, the reason we would use this is because there's no u substitution. There's nothing we can let u equal there that would be of any benefit with the du setting right there also. So we're going to do this. So the dv's, all the leftovers, which would be the e to the x dx. So the du is then negative sine x dx. And then the v remembers the antiderivative, and so that's the e to the x. So then we would write this. We say, okay, this would be uv, which would be e to the x cosine x, minus the integral of v du, so that'd be negative, turn to a plus, e to the x sine x. So you're like, oh, okay, now we got a sine. It's like the same thing we have, but it's got a sine in it. So you got to do it all over again. So you let u equal which one? Sine x. And the dv would be, again, the leftover, which is e to the x dx. And so then the du would be cosine x dx, and the v would be e to the x. And so now we got u times v, which is e to the x sine x, minus the integral of v du, which is e to the x cosine x dx, right? No, I know. But, okay, I said I'm leaving out the 3 and the 2 because all that'll do is make 1/3 of 1/2, right? I don't want to get lost in all that right now, okay? So you end up with this, right? Now, what do you notice about that integral? Same thing you started with. So here's what you do when you get one of these repeating things. You write down the entirety of what you've done so far. So what we've done so far is we have our original e to the x cosine x dx is equal to what? Well, let's see. We started here. So it's equal to e to the x cosine x plus what? E to the x sine x minus the integral of e to the x cosine x dx, right? Right? That's what we have at this point. This is equal to all of this. Well, notice this is the same as this. What could we do? Well, what we're trying to find out is what is this integral equal to? Couldn't I take this integral and add it over to this other side? Right? And what would that give me on this side? 0. No. I'm going to add it. So wouldn't there be 2 of those? And then this would be gone? And then just solve for that by dividing by 2? So there's my answer. That's how that works. If you get a repeating one, what happens is after 2 tries, you get back to what you started with. So then you just write, okay, what I started with is equal to all this, and then that should happen. But you're not going to have to do that again. The integration by parts one we do will be just one time. Just go through it one time. Now, you might have to do a U substitution or something. We'll talk about that on like 31, and we'll go through one of those and see that. But you're not going to have to do this sort of thing. But it doesn't hurt for you to see that, right? You go to Calc 2. If you're going to be going to Calc 2 in college, you're going to be getting into those, right? You're going to be doing those and having some of those. We're just not going to take time to practice a whole bunch of those, okay? So anyway, then you were supposed to do, so now you would either, once you got to that point, if it was just an indefinite integral, you just stick on a plus c. If it's a definite integral with a 1 to 4, now you just put your, right, you just put those numbers in. Put in a 4, minus, then put in a 1, and make sure you do parentheses, so because they're not going to work out real nice. Put in a 4, whatever you get, minus, put in a 1, and then just, you keep that. Okay? Yeah, and then with all the fractions, it's even uglier because you have some 1/9 and 2/3, and with the 2 and the 3 in there. But again, it's not bad practice because you're going to have some with fractions and stuff like that. All right, let's talk about 31. What was 31? Give me the original integral. It was x to the third
squared dx.
E to the x squared dx. Right? So now this one might make you think of some sort of U substitution, right? We got let U equal, now I think they told you, didn't they, to let U equal x squared? Yeah. Didn't they tell you that in 31? They actually told you to let U equal x squared. But and I think that would be one of your first thoughts. I mean, this looks like an integration by parts kind of situation, but it's got more to it. It's got that inside stuff that we talked about that we would always look for with U substitution. Now the problem is, if you let U equal x squared, your du is going to be 2x dx. There is an x dx setting there, but there's an extra, there'd be some extra x's, right? Well, if we have extra x's, we said we could solve for x, whatever. So maybe that would be what I would try, right? Sometimes, hopefully you start doing enough of these, most of the time you kind of know what road to go down. Okay, sometimes you may not, so you just, well, I think about all I can think to do really would be U equals x squared. It's the inside. Let's just see where that leads me, okay? So U equals x squared, so du would be 2x dx. I don't see a 2 in here that I need, so I'm going to move that over. So you get 1/2 du equals x dx. So now I'm going to sub that to a new integral, and so this part would be what? E to the u. Now x cubed, we've done this before. X cubed is x squared times x, right? So this x and this dx would be 1/2 du. So there's a 1/2, put the du over here. Now what's left? I got an x squared left, which is u. So I put that there. Now, is that an integral we can do? With what? With what technique? It's not a page 333, right? It's not just a straight answer. Isn't this integration by parts? So the very first integration by parts we did, the xe to the x1. Okay, so we saw yesterday an example where you start with integration by parts and then you end up with an integral. I think we ended up with the integral that was x over 1 plus x squared. We said, hey, you're going to have to do a u substitution on that. Let u be the bottom and finish it that way. Here's an example where you start with u substitution and you end up with an integral that needs integration by parts. So remember what we do in these techniques. What these techniques are is we take an integral that we don't know how to do the antiderivative and we turn it into another integral or an integration by parts. We have a formula that has an integral in it that we hope that integral is an easier or an integral we can do. Now maybe it's hopefully most of the time that new integral is one we just do with a basic antiderivative. Most of the time that's what's going to happen. Okay, vast majority of the time. But sometimes that new integral might need a different technique or another technique used on it. Okay, and that's the case here. So we do a u substitution, we have this. Now the problem with doing integration by parts now is you're already using u here, right? So what some people do is instead of u, they'll use w and v, maybe. You know, instead of u and v, since you're already using it. It's up to you. You could use u again. I don't think it would really be. What would you let the u equal, or what would you pick? You got algebra and exponential. So u would equal u, so it's kind of weird to do that, right? I mean, so I'm going to use w. Okay, so we're going to let w equal the u, and then we'll let dv, again, be what's left, which is e to the u du. And then dw would be 1 du, and v, the antiderivative of that, is e to the u, again, with respect to u. So it's just that. So what do we got? So what's our formula? uv, I guess in this case it'd be wv. So it's those two multiplied together, u e to the u minus the integral of v du, or v dw in this case. So that would be e to the u, that's our v, then our dw is du. And then there we go. Now we're in good shape, because now the integral we can do. So this is u e to the u minus, and then that's just e to the u plus c. But now we got u, so now we got to put our x squareds back in. So it's x squared e to the x squared minus e to the x squared plus c. Oh, and I forgot the 1/2. I forgot the 1/2 out there, so I'd have to distribute that. So I got a 1/2 there, and I got a 1/2 there. Okay, so those are probably not going to see that on the gateway test. I mean, if there is, there's one maybe where you do an integration by parts and you use substitution, or you do use substitution and you need the integration by parts in the same problem. Most of the time, that's not going to happen, but it's good practice, because there's one problem. You got to practice at both, right? You got to practice at both parts of it. Okay, but that just shows you some of the things that can happen. All right, what else? Yes, 18. Okay, so today's all about practicing these things. Like I said yesterday, I think I said this yesterday, we don't have anything new to do, really, for the gateway test, right? That's why I think Tuesday is reasonable. We just practice. Practice. Okay, Macy, what is it? From what to what? Okay. Okay. So again, there's nothing good. Now, cosecant, well, I'll just leave it. That's fine. There's really nothing I could pick for a u. There is an inside. Cosecant squared, the inside of that is cosecant. If I pick that for the u, the du is one we hardly ever do. It's one of our derivative rules. Cosecant is right here. Derivative of cosecant is that, but that's not setting there. Remember, when you pick a u, you want the du, the derivative, to be setting right there, and it's clearly not setting right there, so that's not a good one. So you've got this x, and so it's an integration by parts, right? So you're going to let u, let's see, we got algebra and we got trig. Which one do we want for the u? Algebra, right? Algebra before trig. So u equals x, so the dv is everything left. Cosecant squared x dx. Okay? So du is equal to 1 dx. And the v, we need the antiderivative of that. Now, that is not in our list. I understand. And I am not going to make you do that on the gateway test, but come on. Darn it, that thing is, why does that keep freezing? There it is. No? Yeah, it is. I mean, here is, I'm not going to be able to get the derivative rules of v. Okay, well, I don't know why that keeps doing that to me. All right, so here's our derivative rules, and this one we definitely do need to know. That is on page 333. The antiderivative of secant squared is tangent. Well, the antiderivative of cosecant squared is cotangent, negative cotangent. Okay, so, I'm not going to put that on the gateway test, but on your homework where you've got your notes and everything else, I think you should be able to get that. So that's negative cotangent of x. Okay, and that's one of the reasons I did have you do this one specifically, because it's very similar to one we did in class. Okay, so this is negative cotangent x, which is that. So we go uv, so that'd be negative x cotangent x. Minus the integral of v du, so that negative will turn that to a plus, and this would be cotangent x dx, right? V du. Now, how do we do the antiderivative cotangent? That's not one that we've memorized. What do? Yesterday we did tangent. It's the same thing. How do we do the antiderivative tangent? Cosine over sine and do a u substitution, right? Tangent was number 51. So we write this as cosine over sine, and then you're going to let u equal, what do we let u equal? Sine of x, because the du would be cosine of x dx, which is sitting right there, right? That is sitting right there, which is what we want. So that integral would turn into, so the cosine, that's cosine now. So that is just du, and the sine, that's 1 over u. And so that's ln of u, which u is sine, so it's ln of sine plus c. And then don't forget this stuff over here. Bring that in front too. So you'd have negative x cotangent x plus ln sine x. Oh, wait, I shouldn't have put the plus c on there, right? I should have then done what? Right bracket and put in my pi halves and my pi fours. So I'd have had x cotangent x plus ln sine x, and then right bracket pi fours, pi halves. Now, to do that, think of cotangent as cosine over sine, so cosine of pi halves is 0, sine of pi halves is 1, so that would be 0, so that would make that whole thing be 0, plus sine of pi halves is 1. What's ln of 1? ln of 1 is 0, so when I plug pi halves in, I just get that, and then minus, and this happened to some of you on the quiz. Oh, by the way, I was going to show you those quizzes. We'll see. Maybe we'll do that tomorrow. If you really want to look at it, I can give it to you, but I don't think I'm going to go over it just because I want to have more practice time here. And then, anyway, but some of you made this mistake when you were doing f of b minus f of a. You didn't think of these parentheses because you're subtracting there, so you got to be careful there. And then pi fourths, cosine of pi fourths is root 2 over 2. Sine of pi fourths is root 2 over 2. So that would be 1. And then put a pi fourths there. So pi fourths times 1 would be pi fourths. Plus, what's sine of pi fourths? Root 2 over 2, right? So root 2 over, so this would be ln of root 2 over 2. Who knows what that is? We'll just write it there. Okay? And so there you go. And you can just leave it like that if you want, or you go negative pi fourths minus ln root 2 over 2. Right? You can just leave it that way. Okay? I think I did that kind of fast. Right? So the gateway test is no calculator. So if there's a definite integral, most of them are going to be indefinite integrals, right? So you're just going to do your antiderivative, tack on a plus c. But if there is a definite integral in there, then you do your antiderivative and then do your right bracket, put your numbers in and subtract. F of b minus f of a, right? Fundamental theorem part 2. Which is a whole reason we're studying these antiderivatives, right? We're studying them so we can do definite integrals. That's the point of practicing antiderivatives, so we can use it in f of b minus f of a. Okay? All right. What else? Anything? How about the packet? How about the LH packet? Let's talk about those problems. The U substitution stuff. Because the vast majority of these things are going to be the U substitution, right? Over half of the test is going to be those. Anything there? Yeah. What? Give me an example. What's 35? Sine of 2x times cosine of 2x, okay, dx. So let's talk about that. What do you pick for u? So what's your first option generally to pick for u? Inside, right? Inside. But even more important than that, the reason you pick a u in u substitution is what? The du. You want the du, the derivative, to be setting there also. Some version of that, right? So it'll substitute out. Right? So like here the inside is 2x, right? So the derivative is 2, and that's not really there anywhere. And a constant doesn't do you much. So rarely do you let u be just like a 2x, right? Or a constant, a linear thing. You don't hardly ever do it. So what else could you do? So there's no inside really. There's no bottom. We've done the bottom sometimes, right? But a lot of times that's because it's an ln situation, and then but again the du is sitting right there. So you got a sine and a cosine. Well, what if you let u be the sine? What's the du? Cosine, which is sitting right there, right? That's why you would pick sine for the u. Or could you pick cosine?
Sure.
The derivative of cosine is negative sine, and it's sitting right there. So you could actually do either one in this case. You could actually do either one. So that's the key. U substitution. Why do you pick a u? Yeah, inside, the bottom, those are common ones. But why do you do it really? You do it so that the u, the du is setting right there. So the u is equal to sine 2x, probably be the better choice. And then just because of the negative, no other reason. Now don't forget, you got to kick out a 2 there when you do that derivative. So the derivative of sine 2x is 2 cosine 2x. And sure enough, that's sitting right there. Now this 2 is kind of in the way, so I'll move it over. And we get cosine 2x dx. And so my new integral, I'm going to take that part, cosine 2x dx, that is replaced with a 1/2 and a du. Again, this is the key part of it, substitution, is to replace those things. That's why you do it, isn't it? So you take those things out and put their u replacements in. So we put 1/2 du in. And then what's left is that, well, that's just u. That's just u, right? Sine of 2x is just u. So we replaced all of that with this. Well, that's just a power rule. So that'll go up to 2 divided by 2. So that's a 1/2. Here we got another 1/2 out there. So it's 1/4 u squared plus c, which would be 1/4 sine 2x squared plus c. Now, I forgot we had that one day when we did, and I don't think I don't have a copy of that. Remember the one where we had to split it, the x plus 4 one, over 1 plus x squared? Remember that one? Okay, everybody, go back in your notes. Somebody find it. Somebody that, see who's the most organized here. Okay? Whoop. Somebody tell me what we had for the final answer on that. 1/2 ln 1 plus x squared, which we don't really need the bars, okay? That was it? Okay, that's... Yeah, I'm sorry. That's not the one I was thinking of. Shoot. There was one where we let... It was right about that same time. Yeah, the final answer had like a 1 plus... No. The final answer had a 1 plus x squared, I thought, minus, and then some other stuff. Gosh darn it. It was that same day we did that one, I thought. It was before integration by parts. It wasn't yesterday. I think it was the day before.
Question 41.
I think it was Wednesday. What was the answer to question 41? Yeah, it wasn't 41. Okay. Yeah, it would have been the 17th. It started with a 1 plus. The final answer started with a 1 plus something. One plus, it had a string of about 3 or 4 things on it. This just reminded me of
well, that problem definitely was 41.
This last problem.
Yeah,
that
I think it was. That's 41.
That was 41, but that's not. Yeah, that's not. must not have been in the homework. Maybe it was one we just did.
I didn't know there was one.
Maybe, but shoot. Maybe it was just. All right. Well, I'll think about it and I'll talk about it later. Well, I'll just make one up. Okay. The answer came out. The answer. Let's say your final answer came out to be 1 plus. The only reason I wanted to do something different with it here is I wanted to look on the calculator. Let's say this was what it worked out to be, right? Let's say it ended up being u minus ln of u, plus c, and your u was 1 plus x squared. So you put your 1 plus x squared back in for the u, and you put your 1 plus x squared back in there, right? And it would end up looking like this. Okay, let's just say that happened. And then you went to the back of the book, or you went to the calculator, and the calculator actually had this. I didn't want to talk about it at the time because I didn't want to confuse the issue because we had enough stuff going on. Why is that bottom one the same as the top? What about the plus c? The c is just some constant, right? Some unknown constant. Well, if you add 1 to some unknown constant, what do you got? Some other unknown constant, just an unknown constant, right? So it's like the c kind of absorbs it. It's kind of weird to think c is the same as 1 plus c, but it is. Okay, so if you had a problem like that, now I would be okay with either answer, right? So if you didn't think to do that, I'm fine with that, right? But if you look on your calculator, if you do one on your calculator that had that answer, or you look in the back of the book, a lot of times that 1 would just not be there. You'd be like, why isn't that there? A 2 or whatever else it might be. That's because it just gets absorbed up with the C, right? So I remember that problem the other day. I was going to say something and I won't get into it right now. Okay, and then I forgot to mention it again. All right. Anyway, so that was that. So 35. So we took care of that. All right. Let's look at this. If there aren't any other things right now on our website, under the left-hand, or down on the left-hand side of the website where it says web links, and we had some of this before, and I'll put it under our assignment page for today too. But down at the very bottom, I've got antiderivative practice. So I've got a website here that is not bad. It's not great. We've got a lot of problems in our book we can practice. But there's a couple of links here we could go to. Okay, so it says you can find a good review with a little practice on antiderivatives here. So let's look at that, and that's not good. So I didn't think that. Sometimes these links from year to year. You can also try your hand at true-false quiz. I don't think that's very good. Yeah, that's really not good. You can review your integration by parts here. Now, there aren't a lot in the book of integration by parts to practice. I've pretty much given you all the ones in the book that you can do. If you go to this link, it's got some. It doesn't have very many. It's got a few here. Okay, and these aren't bad ones. They got some algebra with an exponential, algebra with a trig. You got some algebra with a log. That's not bad. An arc sine one. We did an arc tangent one yesterday. You're probably not going to get one like that. Here's one you're going to have to do twice because of the x squared, so you can probably stay away from that one. And here's going to be one of those repeating ones like we just ran into with the e, so I would stay away from that. So really the first three here would be ones that you could do, right, if you want to look for some practice. That's not very many, but that's a couple. Okay, so there's that link. Those I would stay away from. It says lots of practice, antidifferentiation, the arc trig functions. I don't think I've ever went to that one. Yeah, I would stay away from those. We won't be getting into any of those. This is probably the better one. Lots of practice using substitution, taking this quiz right here. Okay, this is probably the best one to do where it'll give you this, like here's a U substitution, you could let U be that inside x, so you just kick out a negative 1/3 and do a power rule, but if you do it with U substitution, you can, and then you can pick your answer, I don't know, let's say it's that one, and it says, oh, you're wrong. Oh, and it even capitalizes it, put exclamation point, that's nice. Yeah, makes you feel good. But anyway, it'll tell you your answer, you're wrong, it'll say try again, okay, let's see what it does if you're actually right. That's wrong again. Doesn't. That'd be nice. It'd be nice if it told you. Oh, and then it'll give you the solution. So it does, yeah. So it waits until you're right to see, and then get the next one. And oh, here's an interesting one. Sine of pi squared. See that around? What are you gonna do? Isn't that just a number? Isn't that like the integral of 7? So what would that be? The integral of 7 would be 7x, right? So this would just be sine of pi squared times x plus c. That's kind of a tricky one, right? But it's just a number. Sine of pi squared is just a number, okay? So anyway, here's one. This would be a good one. This would be more of a U substitution. Now, to be honest, I would probably split this one. I wouldn't do a U substitution. I would split this one apart. Single denominator, right? Single denominator here. Whoa. I would write that as 5 over x squared minus x squared over x squared, which is just 1. So this would be 5x to the negative 2 on that one, and then this would be minus 1. So then that is just a power rule. Right? Yeah, it'd be the integral one. Or actually, I don't know why I split it. You don't have to split it into 2 integrals. Just make it 1 integral, but just do each piece, right? So that'd just be a power rule one. So that's not bad. Yeah, we watch Bearcat TV. All right. So it's got a lot of different ones, so you can go through those. Now, I was thinking there was another one, but it might not be. So there's not quite as much on the website. Now, you could do some search. I haven't searched for a while. You could search for antiderivative quiz or antiderivative gateway. Maybe I'll even do that here a little bit. And see if there's some newer ones or some other ones up here. But anyway, that can give you some examples. But we have a ton in the book for U substitutes at 23 through 73 page on 5.4. So you got a ton of those in the book you can do. It's nice here because you can kind of check your answer. But again, you got those calculators that you can check your answers as well. Okay, let's do this now. Let's spend a little bit of time doing some that I've got here. Let's see. So just get your notes out here, and we're going to spend a little time kind of like just doing a practice, as if this was our gateway test maybe. So go ahead and you can talk with each other. Try it on your own if you want. Compare answers. Let's do those 3. Try those 3 right there. That's a 7, yes. That's a 7 right there. That's a negative 6 power.
I know. Like 3 parts. Not like 1, 2, but like the first 2 parts of the plot. But yeah, like since it's plus and not like multiplication, you just do each part separately. So yeah, that part is two part. It's true. Oh, and not even. Okay, yeah, you're right. It was not that bad. Okay. Are you? Oh yeah. I don't know. It might be divided by four. Oh yeah, it is. Yeah, it's divided by. Yeah. I was like. Yes. Oh. It was the negative 40. Yeah. Super long. Yeah, he still is. He's.
we check number 1? Does everybody have all 3 copied down, please?
No.
Okay, copy them down real quick. Copy the last one if you're not on it yet. Okay, what's the before I show it? What do you have for the first part of number 1?
Really long.
7/4 sine 4x.
Plus 9 arc sine x plus 5/4 x to the 6.
5 what?
5/4 x to the 6.
5/6, I think. You sure that's not a 6? It should be 5.
Sure.
Okay, it should be 5/6 x to the 6. Because you raise it up to a 6 and you divide by 6. Right? Did you say 5/4 x to the 6th?
Yeah.
Yeah, you went up to 6, but I don't know why you divided by 4.
Maybe I distributed.
I don't know. Yeah, you do have to do that, right. So you distribute, that's a good point, right? You're going to distribute first, that's 5x to the 5th, and then this would be 5x to the negative 3rd, right, when you distribute, okay? And what's the last one? And I'll show it here. What was the last term? Negative 5/2 x to the negative 2nd, right? So we distribute here, like Gary said, 5x to the 5th and 5x to the negative 3rd. So when you do this antiderivative, you raise it up to a 6, divide by 6, so that's why it's 5/6 x to the 6. And then you raise this up one is a negative 2, divide by negative 2, and so that's why that becomes that. Okay, so that would be one. We really talked about 3 different things here, and these 3 actually all represent those. Basic antiderivatives, of which this would be. These are just ones right off of page 333, except you got to take out a 1/4 here. You got this 9 sitting up here, which you can just pull outside for that piece, right? That's just 9 arc sine. And then distribute, so you got a little algebra maybe do, and then just power rule, right? So that would be, what I'm trying to do with this little review here is try to give you ones, get a sense of what will they look like, what could they potentially look like on the gateway test. So that would be one in line with just basic antiderivative using the ones on page 333. Okay, and then we did U substitution, right? What did you pick on the second one? Isn't it a U one? What did you let U equal? Square root of x, or x to the 1/2, right? Let U equal that. And so the du would be 1/2 x to the negative 1/2, which is 1/2 square root of x, which is what's sitting right here, except for the 2, right? So, or except for the 1/2. So we would, right? So we got 1/2 x to the negative 1/2. I'm going to move that 1/2 over there to get it out of the way. This is 2, so we end up with x to the negative 1/2, which is that 1/square root of x dx. So sure enough, let me circle that. So sure enough, I've got this right here is just 2 du. So 2 du. And this part here is just sine u. Oh, shoot, I just realized I didn't finish this, didn't I? Definite integral. Good, yeah. Definite integral. And I'll, on the gateway test, I'll remind you, as you're doing, I'll say, hey, don't forget the plus c's, or, hey, if it's a definite integral, make sure you, do the right bracket, whatever. Yeah, so right here, I should have done a right bracket, 1 to 4. So we put a 4 in there, square root of 4 is 2, so this would be negative 2 cosine 2, which who knows what that is, we just leave it, minus, and then it'd be negative 2 cosine 1, which, again, who knows what that is. Okay, now you can turn that to a plus, that'd be fine, but there would be your final answer. Negative 2 cosine 2 plus 2 cosine 1, right? But anyway, so you sine, antiderivative sine is negative cosine. We get that. Okay, I'll give you some more time to finish this third one then. now what was the deal with Tuesday? Why was Tuesday bad for the gateway test? Monday night is movie night? Okay. Well, if we would move it to Wednesday, what that would mean, if we move it to Wednesday, what that would mean is Tuesday we would probably, we would either go on to new stuff, or I do have one day next week where we're going to do some packet stuff, like we're going to go back to the packets, and now that we've done some antiderivative, some integral stuff, there's some ones we could pick up there, and some old free response questions and so forth. And there was a day we were going to work on that in class a little bit. So we could do that on Tuesday. And then do the gateway on Wednesday. Is there anybody has a problem with Wednesday more than Tuesday? Of course, you're afraid to say anything, right? Everybody will beat you up. I mean, I give you another night to work on stuff. Yeah, I might do that instead of starting something new. And then, because that was a day I had set aside later in the week, but we could do it that day. Would that be all right? You vote for that?
Yeah.
Okay. All right, we'll do the gateway test on Wednesday. Okay. Give you a little extra practice time, and it might make, if that helps out with like the anatomy test or movie night and all that kind of stuff, that'd be fun. I mean, we got plenty. I mean, you can study this weekend and all that, whatever. But all right. Well, hopefully, if you were going to be ready Tuesday, you'll still be ready Wednesday, so it shouldn't be a problem. Anyway, okay. What do we got on number 3 here? What technique are we using? What technique are we doing? On number 3?
On number 3.
Isn't it integration by parts? It's integration by parts. It's an algebra and a trig. There's no good you could pick for u substitution. I mean, you could do 9x plus 9 on the inside, but then that just gives you the d is just 9dx, right? I mean, that doesn't take care of that 7x it's setting there. You got an extra x, but you can't solve for x if you're, I mean, you could, I guess. You could solve for 9x plus 9, solve that for x, but then you just, I mean, you'd end up with some u's, and then you still have a cosine u setting there, and I mean, it would not, you'd still have to do integration by parts. I mean, there's just no way around it. So you got to do integration by parts. So what are you going to pick for the u? 7x, right? Now, could you pull the 7 out in front? You could. You could pull the 7 out in front because it's all multiplied. I would just keep it and make it 7x. That's what I did here. But you could pull the 7 out in front and then distribute it back to later. But I would let u be the 7x. And what's the dv then, the rest? So it'd look like that. U equals 7x, dv equals that. So the du would be 7dx, and the v would be the antiderivative of this. Now remember, you have to kick out a 1/9 because of that 9 in front of the x. A plus 9 doesn't matter. So you'd kick out a 1/9 sine 9x plus 9. Okay? And then you got a u times v. Well, 7 times 1/9, that's 7/9 and an x, and then sine of that minus the integral of. Now, here's the thing. Remember we said this yesterday. This 7 over here, and can everybody see that? This 7 here, do we divide this over? No, in u substitution a lot of times we do, but that's not what we want to do with integration by parts. The formula is uv minus the integral of v du. We want v times du. Du is 7dx. So we got to take this 7 times that 1/9. That's where that 7/9 comes from. And then sine that. Well, the antiderivative sign is negative cosine. So that negative turns to a plus. And another 1/9 is going to kick out. So you had 7/9 there times another 1/9. That'd be 7 over 81. Okay? Anybody get that one? If you did? A number of people did. Good. Okay? So you were getting there? Good. I just stopped you too soon? Oh, sorry. All right.
It's okay.
But you were good. You'd have got there, right? We know. You'd have made it. All right. So, Well, here, on this next batch, I won't show you the answers for a while. I'll give you more time. We'll go on. All right. Try those right there. Everybody make sure you get all three of those copied down. I'll give you the next couple in case you're getting that far and want to keep going. So make sure you get all three of those copied down here. Okay, everybody got those written down? Some hints here, some hints. What does this look like right here? Is that an LN? LN is only to the first power. It's power rule. This is just, write that as 9x to the negative 3. Then just do power rule. 9x to the negative 3. That's power rule. Okay? That's a cosine. You're going to kick out a... You kick out a 1/8, right? Okay, what about this one? Some hints here. U substitution. What are you going to let U equal? The inside, 6 minus ln x. Because the du is what? Negative 1 over x, right? But the 6 just disappears. And there's a 1 over x setting right here, which is what you want, right? So that'll take care of the du. And then this will be 1 over u squared. Is that an ln? 1 over u squared? There'll be a negative in there. No, it's u to the negative 2. It's a power rule. It'll be a power rule then, right? It'll be a power rule. But by letting u be that inside, since you got that ln, the du is going to be a 1 over x, which is setting right there. There's a 1 over x setting right there. Okay, what about this one? Integration by parts. You got some algebra, and then you got log. There's no good u to pick. You can let u be this, but then you get like an x to the 4th, and there's no x to the 4th setting there. So this is algebra and a log. What do you let u equal in that situation? The log. You'll let u equal that, and the dv will be the rest of that. Okay? All right, so there's some hints for you on those. Okay, here's 7 and 8. Here's 7. I'll put the answers up here at the end of class, so you can, if you want to take a look at it. I'll actually post these. Post this on our assignment page for today because it's got the answers farther down the sheet. So it's just a PDF, and so I'll just post it so that you got it down there. So there's 7 and 8. Oh, there's a couple more. Let's put 9 there. So here's 7, 8, 9. So you can jot those down. Here's another one. Here's number 10. I'm sure to get these copied down. I got one more on here. I'll get to it in a second. So on 10 here, what do you think? I mean, let's say it is U substitution. What would be your options for a U substitution? Okay, I heard 2x. Now that's actually correct. But one option would be the bottom. What would you want that integral to look like if you were going to let u be the bottom, the 1 plus 4x squared? No, that's if you're doing 2. If you're going to let u be the whole bottom, 1 plus 4x squared, what would you like to see up here on top? An x. If this was 3x on top, then this would be a u substitution. Because the derivative of 1 plus 4x squared, the du is going to be 8x. And that x dx, that could take, if there was an x there, but there's not. So then it's an arctangent. That's right. Then the next thing you think of is this is like a 1 plus something squared. It's like a 1 plus u squared. What would the u have to be? 2x, right. So that's your thought process, how you would know to let u be 2x there. Because then then the du of that's just a number, which we can deal with. That 3 we can pull out in front. And then the bottom ends up being 1 plus u squared, which is an arctangent. That's your thought process on it, right? If I let u be the whole bottom, if there was an x up here, that'd be good. That's what I would want to do. All right. So for your homework, I think for the weekend, it's just a lot of practice. So you've got those 11 problems. You can finish those. I will post that PDF under our assignment page. I'll also post a link to that antiderivative site. So you saw some pages. Now, this is kind of a mess of different things, but here's your assignment sheet. So why don't you grab your assignment sheet real quick. But you probably want to leave some of these, obviously, to do next week as well. But this would be a main part of where I would work on some u substitution problems. We've already done this line here. That was for today. We've already done this line here. That was for today. So all of the rest of this stuff, and it's just kind of a hodgepodge here I picked in the LH packet. Now, the way the LH packet worked, it's from that old book. And the old book used to do, it divided up its chapters by types of functions. So you'd learn derivatives and integrals and stuff on algebraic type functions and do a bunch of stuff. And then the next chapter might be exponential and log functions, and the next chapter might be trig. So I think like 341, I think might be some exponential log kinds. And I think 356 is maybe some trig ones. And 310 is mostly algebra ones. So I just picked out some. You could do other ones too that are around those. But that's all I did here was pick out some that, okay. So those are mostly u substitutions. The only ones that are integration by parts are going to be the ones that say 8.1. Those are the only ones that will be integration by parts. Everything else on here, all these LH ones are all going to be u substitution type situations. So to get some integration by parts practice, you're going to have to go to that website, and there was only about 3 of those. And I got a couple more here. But again, you can make up your own. I mean, just take an algebra, just take a 3x and throw it with an e to the x or an ln x or a cosine x. Remember we said it's kind of a mixture of function families? So you start noticing that those integration by parts always kind of look alike, at least the ones we'll be doing. Okay? So you know, do a bunch of problems. I would think over the weekend, my gosh, 20 ought to be a minimum before Monday, you know, of just practice ones. But it's up to you. just think about that page of 11 we had. What were your chances of getting 8 of those right? That's the one. Thank you. Yeah. It was number 10 on Tuesday's assignment on section 5.4, the one that had 1 plus x. What is it? 1 plus x minus ln of 1 plus x. Yeah, that's the one where the 1, if you did on your calculator, the 1 wouldn't be on there. It would just get taken up with the c. So